So far, everything we've done has been involving one equation, but we'll take a look at this scenario here. You'll notice right away there are two different things going on here. You've got two variables here, so this is like the equations we've been doing with main floor seats and floor level seats. So you've got two equations there, but notice there are two things we're doing with those seats. We have them selling for 62,000. But then we also have a total of 2,000 tickets sold. So the question is, how do I solve this thing, and how do I figure out how many main floor tickets and how many upper level tickets were solved? We can do this using something called a system of equations. That's what we're going to be looking at with this lesson. So we'll come back to this problem in a minute. But let's write down some definitions first. A system of equations basically is when I have two or more equations that contain two variables. And a solution for that is when I have an ordered pair or a set of values that I can plug in and I can set, and so that the two sides are equal. So when we write these equations, what we're going to do, we're going to use x and y. We're going to use x and y for our variables, and that's going to make it a little bit easier to relate this to the coordinate plane, which is something we'll look at later. So let's look at how we determine whether or not an ordered pair is a solution. Remember that when I look at -2, 4, -2 is the x coordinate and 4 is the y coordinate. Very, very basic. So all I have to do here is I have to plug these values in. So I'm going to plug them into these equations. First of all, I'm going to do 2x plus 3y equals 8. Notice I plug the -2 in for x, I plug the 4 in where I see the y, and then I'm just going to do some math here. And I end up with -4 plus 12 equals 8. Remember, -4 plus 12, those are working against each other, so I end up with 8 positive. So this part checks out, but I still haven't figured out it's a solution for the first equation. Now I have to figure out, is it also a solution for the second equation? It has to be a solution to both of these, otherwise it's not a solution of the system. So it has to work for both equations if it's going to work for the whole system of equations. So just running down some math here, I have -2 minus 16. And notice -2 minus 16 is -18. It doesn't work for this equation, so it's not a solution for the whole system. All right, let's try this other one. Let's plug in 7 for x. I'm going to go back to the first equation. I'm going to do 2 times 7 plus 3 times -2, and we'll see if that equals 8. If it does, it's a solution for this equation. Remember what solutions are. Solutions are values that I can plug in that make the two sides equal, that make the statement true. One side equals the other. 14 plus -6 is 8, so this is a solution. Let's try it in the other one. We're going to do 7, that's the x value, minus 4 times -2, the y value. That gives me 7 minus -8. If I subtract a negative, that's the same thing as adding a positive. Take away a negative, add a positive, same thing. So I get 15 equals 15. Notice it checks out for both equations. Therefore, it is a solution for the system of equations. And that's the system of equations are those two variables there. One more, let's just plug it in here. 2 times 11 plus 3 times -1. Plug x in for x, y in for y. So you have 22 plus -3. You probably see right now, this is not going to equal 8. It equals 19. So this is right away, I don't even have to plug it into the other one. Since it doesn't work in the first one, it obviously is not going to be a solution for the system of equations. All right, let's talk about how we find these solutions then. Notice how here I have y equals x plus 3 and I have y equals 2x plus 5. Well, if y equals both of those things, then I can plug in, instead of writing y equals 2x plus 5, I can write x plus 3 equals 2x plus 5. Because y and x plus 3 are the same thing. I could also go the other way. I could plug 2x plus 5 in for the y on the x plus 3 equation. And then all I'm going to do is I'm going to solve this equation the same way I solved when there were variables on both sides. Now I end up with x is -2. That's my x value, but I'm not done. Because remember, for a system, I've got to have an x and a y. It's a set of values. So all I need to do now, I know the x value. I just plug it in for y. So I did -2 plus 3. So my ordered pair here is -2, 1. That's about as easy as it gets because I know I already have y isolated. Look at these two problems. Here, y is not by itself. So an x is not by itself. So what I need to do is I need to get one of those variables by itself so I can plug it in. So notice I have this x plus y equals 5. I'm going to go ahead and I'm going to isolate one of those. It wouldn't make much sense to isolate the y in the second equation, the x minus 2y equals negative 4, because then I'd have to divide by 2. I'd end up with fractions. Whenever you're deciding which variable to isolate, always pick the one that's going to take you the least amount of work, obviously. Okay, so when I isolate the variable for this first one, okay, I'm going to get rid of x. I'm going to move x to the other side. This is like solving for a variable. We did this before in 10-5. I get y equals 5 minus x. And now I can plug that into the y in the other spot. This gets a little tricky because I have to use the distributive property. I end up with x minus 2 times 5 minus x. And now I have to do basically negative 2 times 5 minus x. So negative 2 times 5 is negative 10. Negative 2 times negative x is positive 2x. Now I can combine like terms. I have 3x minus 10 equals negative 4. And then I'll add 10 to both sides. And I get 3x equals 6. And I'll solve that for x. Now remember, this only gives me the x value. It does not give me my final answer. Once I have the x value, now I've got to go plug it back in. Make sure you plug it back into one of your original equations. So I'm going to plug it back into the x plus 5 equals y, because that's the original equation. Don't plug it into the one where you move the variables around. Because if you made a mistake moving the variables around, then that would mess up your answer here. All right, so my ordered pair is 2, 3. Okay, going to the next one then. Notice, again, being strategic about which variable I'm going to isolate. It wouldn't make sense to isolate either x because they both have a coefficient. The first equation has a coefficient of 3. The second equation has a coefficient of 4. For the y's, I could isolate in the second one, but notice that has a coefficient of 2. But the one above, equation 1, there's no coefficient on that y. So that's the one I'm gonna isolate. I'm gonna get in that first equation, I'm gonna get that y by itself. That means I have to subtract 3x from both sides, so I get 8 minus 3x is what y is, and then again, just like I did before, I'm gonna plug that in for this y right here. Okay, so I have 4x minus 2 times the quantity 8 minus 3x, and that equals 14. I'm going to distribute. So I have 4x minus 16, and then negative 2 times negative 3 is positive 6. Okay, and then again, combine like terms. 4x plus 6x is 10x, minus 16 equals 14, and then it's just solved like normal. Again, I want to say it too many times here. I'm getting x. This just gives me the x value. It doesn't give me the final solution. It just gives me one of those values for x. So x equals 3, and now I've got to figure out what y is. It doesn't really matter which equation I plug it into. It doesn't appear that either of those would be any easier than the other one, so I'm going to plug it into the second one. So once you have your x value, x equals 3, all you have to do is plug it in. It doesn't matter which equation you plug it into. I plugged it into the second equation, and you'll notice here I did 4 times 3 minus 2y equals 14. I just multiplied, did the work on down. I ended up with negative 2y equals 2, and so y equals negative 1. So my final solution here is 3, negative 1. Now, little comment here. You should never miss any of these problems. If you plug it back in, plug in 3, negative 1, or in the previous problem, you can plug in 2, 3. You can plug them back in for x and y, just like we did in the first example. It should work for both equations. So it should check out here. And that's one way to make sure you never miss one of these problems, because there are a lot of steps. Okay, so now that we've taken a look at how to kind of work these problems, what we're going to do next is we're going to go back to that word problem and talk about how to apply this in real life. So we've got here tickets for a concert, and remember there's 2 variables here. We talked about this at the beginning. There's main floor tickets, let's call that x, and upper level tickets, let's call that y. Now there's 2 bits of information they give me about x and y. They tell me how many total tickets I sell, and they tell me how much money I make off of those tickets. So little information, let's highlight that information. I have $40 for x and $25 for y, and that's each Okay, and I have a total. Total, you should be thinking, okay, if I add up the number of tickets I sell, I get 2,000. So that means I add X and I add Y and I get 2,000. Notice that's an equation. Now this is a system because there's another equation I could write here. One's for the total number of tickets and one's for the total amount of ticket sales. I have sales from the main floor tickets, $40 each. That would be 40 times X. I have 25 each for the upper level, so that's 25 times Y. So my equation, if I add those two terms together, 40x plus 25y equals 62,000. And now I can solve this using the method we've been doing. I'm going to take the first equation and isolate that because there's no coefficients. I'm going to get y by itself. You could get x by itself too, it doesn't matter. So I get y equals 2,000 minus x. I'm going to plug that in where I see y in the second equation. So I'll write 40x plus 25 times 2,000 minus x. I'm going to have to distribute the 25 equals 62,000. Okay, when I distribute that, I'm going to have to do 25 times 2,000, so let's get a calculator out just to make sure we get this right. No sense making a calculation mistake. 25 times 2,000 is 50,000. So my new equation after I distribute, I have 40x plus 50,000 minus 25x equals 62,000. And then I'm going to combine like terms and we'll solve. So I have 40x minus 25x, that's 15x, plus 5,000 not equals 5,000, 50,000 I should say. Don't lose a zero, equals 62,000, and then we'll just solve this down. Now notice what I'm solving for here. I'm solving for x. Don't lose sight of what x means. That's the whole purpose of using algebra, is we can represent what that variable stands for, what it means. So I have 15x equals 12,000, because that's what 62,000 minus 50,000 is. Then divide both sides by 15. I'm going to take my calculator out here, 12,000 divided by 15. So x equals 800. Now think about what that is. That's 800. Remember we said 800 was the main floor seats. So that's 800 seats on the main floor at that higher $40 price point. Now to figure out how many upper level seats I sold, I can plug that back in. Now I can plug it back into either equation, but why wouldn't we just plug it back into the easier of the two equations? If I plugged it back into the second equation with the prices, I'd have to do 40 times 800 plus 25y and solve that out, which we could easily do, but it's probably easier just to do 800 plus y equals 2,000, especially because this is the number of tickets. If I subtract 800 from both sides, I get y equals 1,200, and remember, that's 1,200 upper level seats. You can refer back to this problem when you do the word problems, but the key here is recognizing what are the two different types of information that they're giving you about the variables. Let me know if you have any questions. Good luck.